Lecture 27, follow up to Lab 11, Introduction to Binomial Distribution. We should consider 95% confidence interval or 5% p-value. Use tornadoes data and your statistical expertise to answer the question below. Is it reasonable to claim that there are more tornadoes in April than on? We need to compare the average tornadoes between April and August and see whether there are more tornadoes in April. So that means it is one-tailed t-test. I have uploaded the tornadoes data. Now let me go for April and August data. Let me select both of them. Control C, come up with a new worksheet and Control V. Before trying to go for one-tailed t-test, we need to check whether the averages of the data backs our assumption or not. The average of April is 101.8. Average of August is 57.71. So clearly the averages backs our assertion or the claim. So we can go for one-tailed t-test. So let us write t-test array 1. The first array is this one, comma, second array is this one, comma, this is one-tailed test and we need the p-value. Okay, so this is 4.0875 e to the negative 06. So that's a very small one. 4.08 to the power negative 6. Write a one-line statistical interpretation. P-value is small than in August. Okay, one-line conclusion. Yes, it is reasonable. Let's go to task 2. Use tornadoes data again and your statistical expertise to answer the question below. Is it reasonable to claim that the years with more observed tornadoes are also the years with more tornadoes death? The year with more tornadoes means years with more tornadoes death. Then that means it is giving us the relation between the more observed tornadoes leads to more tornado death. So we go for regression. Okay. Use the column containing annual tornadoes versus column with annual tornadoes death. Okay, so let's go for that. Then let's go to the original one. So annual tornadoes, total number of tornadoes and total number of death. Control C, come up with a new. Okay, now we need to go for regression. So data analysis, regression, click on OK. Input Y range. Y range is this one, since more tornadoes leads to more death. That's what it is saying. Okay, so column B is the input Y range and X range is this one, the number of tornadoes. Okay, there are levels and click on OK. So here's our regression table. The p-value is 0.349. One-line statistical interpretation. So since p-value is large, that's 0.34, which is greater than 5%, that's 34.9%. There is no statistical evidence that year with more tornadoes leads to more death, more tornado related death. Our claim is not reasonable. So task 3, use tornadoes data and your statistical expertise to answer the question below. Is it reasonable to claim that an average October has less than 4 tornado related deaths per year? We need to compare the average death in October with a fixed number 4. Okay, so that means we need to go for confidence interval. Okay, October death. So let's go to October death. Death in October is this column Y, Control C. Okay, confidence interval. So the average is 1.8. Standard deviation is equals STTEV. Margin of error equals confidence dot t. Alpha is 0.05, standard deviation is this one, comma, there are 46, that means 45 data, 45 number. So that's the margin of error. Now confidence interval is given by equals to average minus margin of error, and that's the left endpoint. The right endpoint is average plus margin of error. So that's it. So 0.69 up to 2.90 is our confidence interval. One line statistical interpretation, less than the number 4. Okay, confidence interval is less than number 4. So okay, confidence interval is less than 4 since the confidence interval goes from 0.69 up to 2.9, so which is less than 4. So we can say that we are 95% confident that October has less than 4 tornado related deaths per year. Okay, one line conclusion. Yes, it is reasonable to claim that October has less than 4 tornado related deaths per year. Okay, task 4. Your insurance company has coverage for three types of car. Annual cost for each type of cars can be modeled using normal distribution. Use the following parameters. Let's go for random number generation. That's data analysis, random number generation. Click on OK. Number of variables is 1, and let's go for 1000. Normal distribution, mean is 520. Standard deviation is 110, and randomly leave that empty. Click on OK. So that's fine. Okay, now let's go for the second one, data analysis. Click on OK. So everything is fine. This should be 720, mean is 720, and this is 170. Click on OK. So we get the second one, and now third one is 470, and this is 80. Click on OK. So this contains car 1, this contains car 2, and worksheet 4 contains car 3. Use either sorting or construct the appropriate histogram or rule of thumb to answer the question. So let's go for a rule of sorting. So car 1, go to home and click on sort and filter, smallest to largest. That's fine. Now do the same thing for car 2. Sort and filter, smallest to largest, sort and filter, smallest to largest. Okay, what is approximate probability that car type 1 has an annual cost less than $350? So let us find $350 in car type 1. That means car 1. So this is car 1 and $350. Now here you can see that you can just scroll down and see 350. So we have 353 but no 350. So we want the data below 350, means we will go up to 46th row. Okay, probability less than $350, okay, is equal 46. That is the total number of cars that required less than $350 of maintenance per year. So divided by 1000 is 0.046. Okay, it says that answer should be approximately 35 to 85, so that's 3.5 to 8.5. So that's fine, 0.046, since there were 46 lesser value than 350. Okay, so for the second one, which of the three types of car is least likely to cost less than $350? So for that, we have already gone for car 1. For car 2, let's find 350. It's pretty close. Less than 350 is just 8 of them. Okay, so P less than 350 equals 8 divided by 1000 is 0.008. And the last one, less than 350 is, okay, less than 350 is 70 of them. So this would be, yeah, P less than 350, 70 divided by 0.07. So clearly car 2 is the least one. Okay, so that's fine. Which of the three types can we expect that approximately 90% of the cases will be between 300 to 740? Let's go for car 1 and find out 300 to 740. So 300 lies in 18th row. Okay, so that's 18th row. Let me just mark it. And let's find 740. So 740 is up to this one, 984th column. Okay, we need to be in between 300 and 740, so we go for 984 column, 984 row. Okay, then our total number of cars that lies in between these two values is up from 300 to 740 is simply equals this minus this. So that 966. Then probability is P from equals 966 divided 1. Okay, so that's 96%. Okay, so that's 96.6%. Okay, so that's for car 1. For car 2 also, let's do the same thing. This is 2. 300 means greater than 300 means from row 2 up to, let's go for 70. Control F and type 740. Okay, up to 740. This is 520th row. Let's go for 521. Oh yeah, 521 minus 2, that's just 520. Control home, that's just 520. Okay, I don't need to do any calculation. So equals 520 divided by 1000 is 0.52. That's just 52%. 52% of the cars maintenance cost lies in between $300 to $740. Now for car 3 also, let's find this one. Okay, from 15 up to, Control F, so that's 15, and so you can see that we have 740 means this is 999. Okay, so and only one value is greater than 740, so 999. So you can simply go for 999 minus 15. Oh, you should go for 1000 minus 15. Simply you can, so here you can simply avoid 15 numbers. Okay, 1000 minus 15. So 1000 minus 15 is simply 985. Okay, so 985 divided by 1000 equals 0.985. So that's 98.5%. Okay, 98.5%. Okay, so car 1 96.6%, car 2 52%, and car 3 98.5%. So let's read the question. Which of the three types of car can we expect? Approximately 95% of the cases will be this one. So we would go for this one, 96.6%. So that's car 1. This could also be answered using the sorting argument described by above, or by 2 standard deviation rule of thumb. Namely, this rule states that car type 1 should have almost 95% of the data between mean minus 2 standard deviation, mean plus 2 standard deviation. So that's 740. So this is the one of the basic thing that we discussed in the class in first few weeks, first 2 or 3 weeks. Okay, now let's go for task 5. Imagine an experiment where 3 dice are tossed and number on each die is recorded under die 1, die 2, die 3. Answer the following questions about the same sum of number 3 recorded from die 1, die 2, die 3. Equals to 10, greater than 10 and greater than 9. Since we are rolling a die, we need to make sure that Excel understands what we are doing. So outcome, and this is probability. Now probability is simply equal 1 over 6. Probability is simply 1 over 6. And let me drag it down up to 6th row. Okay, so this is 1, 2, 3, 4, 5, 6, since there are 6 sides in a dice. Okay, so we have come up with this probability. Now we want 3 dice. Okay, we want to roll 3 dice. Let's go for data analysis, random number generation, click on OK. We want 3 variables. We are rolling 3 dice, and let us do for 1000, and discrete data and value and probability input range is simply A2 up to B7. So that's fine. Click on OK. So we'll get these 3 dice: first die, second die, third die, and first roll, second roll, third roll, and so on. So column D will consist of equals to sum of the all of these rolls. Okay, that's fine. Now click on enter. Then this is, so hover in the right bottom, double click. Then if you go to the end of the document, means end of the data, then you can see everything is summed up. Control home. Okay, so that's fine. Now let me again do the similar kind of thing. Since here we have sum of 3 dice and here we have sum of 2 die, first die and second die. So let me go for let me be careful and let me go for first and second die also. Okay, so here equals sum of first and second die, means A1 and A2. Okay, sorry, A1 and B1. So that's it. That's the sum of 2 dice. Let us remember that D is sum of 3 dice and E is sum of 2 dice. Okay, yeah, all right. Now for the beans of for first 2 numbers is, beans would be, since the sum of 3 dice would be at most maximum 18 and the least sum can be 3. So 3, 4, 5, 6, 17, 18. Okay, so that's fine. Now these are the beans for sum of 3 die. Now let's go for the bean of 2 die. That's just 2 to 12. Okay, so that's 2, 3, 4, 11, 12. Okay, so now let us go for D and F. So data analysis, histogram, click on OK. Input range is from D1 up to D1000, $D, $1 up to $D, $1000. This is $1. Okay, so bean range is this one, F1 up to F16. Okay, click on OK. So that's our frequency. We don't need to go for a histogram. Now let's go for the sum of 2 die. Sum of 2 die is again the same thing: data analysis, histogram, click on OK. Instead of D1 we go for E1 and E1000 up to E1000. And this bean range is certainly a different thing for this one, so G1 up to Z11. Okay, so click on OK. So this is the frequency table of sum of 2 dice. Now okay, let's read the question. What is the approximate probability that die 1 plus die 2 plus die 3 is equals to 10? So for this one, okay, equals to 10 means 115. Okay, so that's probability is equal 115 divided by 1000. 0.115. And what is the approximate probability that die 1 plus die 2 plus die 3 is greater than 1? Sorry for the internet, it's not working. So what is the approximate probability that die 1 plus die 2 plus die 3 is greater than 10? So greater than 10 means you need to go for all of these values. Okay, so that means you can just write, and the probability is sum from 11 up to 18 divided by 1000. So that's 0.501. What is the approximate probability that die 1 plus die 2 is greater than 9? Die 1 plus die 2 is greater than 9. So for that I need to go for this one. Greater than 9 means I should go for these three. Okay, so the probability is equal to sum of these three divided by 1000. Okay, 0.177. Okay, so that's all. My internet, I don't know why it's not working.